Next chapter is integration and some formulae of integration. So integration of constant, that is 1 dx is what? X. That is, if there is 2, then it is integration is 2x. So that is integration of k is what? Integration of k is kx plus constant. Integration of x raised to n is what? X raised to n plus 1 divided by n plus 1. Integration of 1 by x is log x. Integration of x raised to minus 1. X raised to minus 1 means 1 by x is log x. X raised to minus n, again in x raised to minus n plus 1 divided by minus n plus 1. Same formula. 1 by ax plus b is 1 by a log ax plus b. That is, if there is a in place of x, there is ax plus b type factor. That is linear factor, polynomial of degree 1. Then its rules are same, but only divide by a. That is 1 by x log x. Integration of 1 by x is log x, and 1 by x plus b is what? Log x plus b divided by a, or into 1 by a. Similar the rules. Integration of cos x is sin x. Integration of sin x is minus cos x. Integration of sec square x is tan x, because derivative of tan x is sec square x. Then derivative of sec x is what? Sec x into tan x. So integration of sec x into tan x is sec x. Integration of cosec x is minus cosec x into cot x. So integration of cosec x into cot x is minus cosec x. Integration of derivative of cot x is what? Minus cosec square x. And that's why the derivative integration of cosec square x is minus cot x. Integration of tan u is log sec u. Integration of cot u is log sin u. Integration of sec u is log sec u into tan u. That is, integration of sec x is log sec x plus tan x. In this way, the another formula, integration of cosec x is what? Log cosec x minus cot x. So remember, integration of e raised to x is itself e raised to x. Integration of a raised to x is a raised to x divided by log a. In the derivative, it is into log a. So these are some rules of integration. Integration of root a square minus x square is what? Sin inverse x by a. And integration of x a square plus x square, or x square plus a square is 1 by a tan inverse x by a. Integration of x root x square minus a square is 1 by a sec inverse x by a. This way, integration of sin square u, tan square u, all these formulas. Integration of a square minus u square is 1 by 2 log u plus a divided by u minus a. 1 by u square minus a square integration is 1 by 2a log u minus a divided by u plus a. Integration of root a square plus x square. So all these formulas are the formula of integration. Already we observed in the 12th standard, then at a F.Y.B.Sc level, this integration chapter. Okay, so here is the chapter is multiple integrals, that is double integral and triple integral. So we observe some graphs of the functions. So this is very simple graphs of the functions. That is, suppose this is the equation of straight line ax plus by plus c is equal to 0. And this is general form of the line of equation, straight line. Y is equal to mx plus c is the slope intercept form, and y is equal to mx is again slope intercept form, but passing through the, if the constant term is not present, then the line passing through the origin 0, 0. So these are the forms of the equation of straight lines. And how can draw the lines? Suppose y is equal to x, that divides the first quadrant and third quadrant in two equal parts. That is, this is y is equal to x. Its slope is 1. Y is equal to 2x, that is, its slope is larger than y is equal to x. So it is above the y is equal to x. Y is equal to 3x. Y is equal to 1/2 x, below the y is equal to x. So here is the constant term is 0. That's why the line passes through the origin. This is y is equal to minus x. Each point on the line is what? X coordinate and y coordinate, there is difference of sign. So this is the equation of straight line. So y is equal to mx plus c, or y is equal to mx. So if c is not equal to 0, so y is equal to ax plus b. This is the line y is equal to ax plus b. That is passing through the point. The line passing through the point. What x, if we substitute x is equal to 0, then y is equal to b. So 0b. This is 0b point. X coordinate is 0. Y coordinate is b. And if we substitute y as 0 in this equation, then we have x is minus b by a. So this point is minus b by a 0. So this is the line. So if we draw the line y is equal to 4x plus 2, we can draw the line y is equal to 4x plus 2. This line is in this form. So substitute x is equal to 0, we get y is equal to 2. And if we substitute y is equal to 0, then x is minus half. So this is minus half 0 point, and this is 0, 2 point. So this line passes through actually this line y is equal to 4x plus 2. So uh, the graph of the straight line is very simple. That is, if there is no constant term in the equation, then the line passes through the origin. And if there is constant term, then determine 2 points. That is, substitute x is equal to 0, find y, and then substitute y is equal to 0, find x, and denote that 2 points, and the line passes through that 2 points is the graph of that line. So y is equal to plus minus mx square, or y is equal to plus minus 4ax square. So these are the equations of parabola. These are the equations of parabola. Y is equal to plus minus mx square. So this parabola is what? The equation of this parabola is y square is equal to mx. So if the square of y, then it is around the x-axis. Y square mx is around x-axis, and y square minus mx is around the x-axis, but my y square is minus mx. That's why it is to the left of the y-axis, and to the right of the y-axis, y square is equal to mx. And if there is a square of x, then it is around y-axis, x square my. This is x square my above the x-axis, and below the x-axis is what? X square minus my. That is, if y square is there in the equation of parabola, then it is around x-axis, and x square is there, then it is around the y-axis. The parabola is around y-axis. Okay. So the equation of this is equation of circle. X square plus y square is equal to r square with center 0, 0. And if the equation is in this form, x minus a square plus y minus b square is equal to r square, then its center is AB. Okay. So, and radius is r. So these are some graphs of the functions, very simple graphs of the functions. Now, this minimum knowledge is required for the chapter integration. That some graphs of straight lines, parabola, and some formulae of integration. So now we are going to start the integration chapter. The first is what? We are going to start the integration chapter. So first is what? Hobini's theorem, or its first form, Hobini's theorem. So if fxy is continuous throughout the rectangular region, are subscribed as x is less than or equal to b greater than or equal to a, and y is less than or equal to d, and greater than or equal to c, that is, this is rectangle. Then double integration over r fxy dA is what? is integration c to d a to b fxy dx dy, or integration c to d, the integration c to d is on y, so write dy first, and a to b fxy dy dx. That is, this Hobini's theorem states that if the limits are constant, then order is not matter. That is, we can integrate with respect to x first, or we can integrate with respect to y first. That is, if the limits are constant. So we will going to use this theorem in the examples. That is, if the order is if the uh, limits are constants, then order we can change the order easily. That is integrate with respect to x first, or integrate with respect to y first, if the limits are constants. But if the limits are not constant, then the Hobini's theorem is called strong form. This is the first form or weak form, and this is the second form, or is called strong form. So R is the region defined by the this a less than or equal to x less than or equal to b, and y is what? Less than or equal to f to x and greater than or equal to f1x. That is, the limit of y are functions of x, not constants. F1 and f2 are continuous functions on a. Suppose fxy is continuous on r, then double integration over r fx dx fxy dA is equal to double integration over r fxy dx dy, and then it is integration f1x to f2x. Y runs from f1x to f2x. Here write y is equal to either y is equal to f1x to f2x fxy dy, and then integration a to b dx. That is, first integrate with respect to y, and then integrate with respect to x. So here is the order of the integration is what? First with respect to y, and then with respect to x. So we cannot integrate with respect to x first, because integration of a limit of y is function of x is not constant. If the limit is constant of both x and y, then order is not matter. That is, either integrate with respect to x first, or integrate with respect to y first. But if the limit of the y is variable in terms of variable, and limit of x is constant, then first integrate with respect to y first, and then integrate with respect to x. Here is, if the limit of, suppose x is in terms of variable, that is in terms of y, and suppose limit of y is constant, then what is the order? That is, then or integrate with respect to x first, that is x runs from g1y to g2y, and then integrate with respect to y. That is, if the limit of that variable is not constant, is in variable form, that is, the limit of one of them x or y is in the variable form, then integrate with respect to that first, and then integrate with respect to another variable whose limit is constant. So these are the Hobini's theorem, first form and second form, or weak form and strong form. So we are going to use this theorem in our example. So first example is what? Evaluate double integration over r fxy dA is equal to, where fxy is 1 minus 6x square y, and r is the rectangle, runs from 0 to 2, x runs from 0 to 2, and y runs from minus 1 to 1. So double integration over r fxy dA is equal to, is integration minus 1 to 1, integration 0 to 2. Right here, for simplified purpose, right here x is equal to 0 to 2, and here write y is equal to minus 1 to 1. Then 1 minus 6x square y fxy is 1 minus 6x square y, and dA means what? Dx dy. So here we integrate with respect to x first, and then with respect to y. So instead of this, we can also integrate with respect to y first, and then with respect to x, because the limits are constants. If we have to integrate with respect to y first, then write integration 0 to 2, x runs from 0 to 2, and then write in bracket integration y runs from minus 1 to 1. That is, write this integration next place, and this integration in the first place out of this bracket, and then 1 minus 6x square. Here write dy, and then bracket dx. That is, if you have to integrate with respect to y first, then write in this manner. So here the limit of x and y both are constant. So first integrate with respect to x or with respect to y. We get the same answer. So minus 1 to 1. So integration with respect to x, integration of 1 is x, and here minus 6y is now constant. And the integration of x square is by using x raised to n rule, x raised to n plus 1 divided by n plus 1, that is x raised to 2 plus 1, that is x raised to 3 by 3. So 6 by 3 becomes 2. And x runs from 0 to 2, right? X is equal to 0 to 2, okay, dy. And then find the value at upper limit, that is substitute x is equal to 2 in this, and then minus x is equal to 0 in this. So write in curly bracket that if you substitute x is equal to 2, we have 2 minus 2 cube is 8 into 2, 16y. This is a value at upper limit of this bracket, minus, if you substitute x is equal to 0 in this, we give the 0 answer. So minus 0, write in curly bracket this, right, curly bracket, this bracket minus in round bracket 0, and then complete the curly bracket. And then next step is this, into dy. And then integrating with respect to y. So integration of 2 is 2y. The integration of constant is constant into variable. Now y is variable. Here x is variable, therefore integration of 1 is 1 into x. But here is y is variable, therefore integration of 2 is 2y. Minus 16, y integration is y square by 2. And so 16 by 2 is 8. And then find the value at upper limit. So is equal to, next step is equal to, substitute x as y as 1, y as 1. So 2 into 1 minus 8 into 1 square, that is 2 is minus is what? Minus 6 is equal to minus 6 in one bracket, minus, substitute y as minus 1. So what do we have? Minus 2 minus 1 square is a plus 1. So minus 2 minus 6 becomes minus 10. So minus become plus 10. Then so minus 6 and plus 10 becomes 4. So this is the way to find the double integration. That is double, if after this bracket, this becomes a single integration. This becomes a single integration. That is double integration and triple integration converted to single integration, and use the rules of single integration. Just remember that if we integrating with respect to x, then y is constant. If you integrating with y, then x is constant. If there is a triple integration dx, dy, dz, that is then integrating with respect to x, then y and z are another variables are constants. If you integrating with respect to y, then x and z are constant. If we integrating with respect to z, then x and y variables are constants. So here is the another problem. Evaluate double integration y sine x into y dA, where r is what? This rectangle. That is x runs from 1 to 2 and y runs from 0 to pi by 2. X runs from 1 to 2 and y runs from 0 to pi, 0 to pi. So y with respect to x first integration. So right, here is the bracket, here right bracket, that 1 to 2, x runs from 1 to 2 and y is equal to 0 to pi. So y sine x into y dx dy, this integration. Okay, so first integrating with respect to x, so y is constant, and sine x into y integration is minus cos x into y, minus cos x into y. This y, right, y as it is. So minus cos x into y, x runs from 1 to 2, right here 2, and then y, right out of the bracket y, the here is y, and then value at the upper limit, that is substitute x as 1. So we have minus cos y, value of this. Take this minus sign here. So minus y in bracket this. So cos y minus cos 2y, minus cos 2y. If you substitute, here is 2, so minus cos 2y. Minus minus become plus cos y. If you substitute x as 1, so minus minus become plus cos y. Here is out of here y, right, y here, this y. So or delete this y from this step. Okay, then y into this. So integration of this is what? Here is y cos 2y, y into this bracket. If we reverse the order of integration, we get, that is, we can also integrate with respect to y first and then with respect to x. That is 1 to 2, right out of the bracket, 0 to pi y sine x into y dy dx, okay. So integration with respect to y first. So here is the substitution. Y u is y, dv is sine x into y dy. So we get du is equal to dy. Substitution, integration by substitution. Okay, integration by substitution. So this is the answer of the problem. Or use the part rule. Use the part rule. First integration of second minus integration of second derivative of first. So use that part rule. We get this answer, 0 answer. First y, integration of sine x into y is what? Sine x into y is cos x into y divided by x. X is constant now. Minus cos x into y divided by x. First integration of second. Don't use this substitution. This is first, this is second. First integration of second, cos sine x into y. Now with integration is with respect to y, therefore x is constant. The integration is minus cos x into y divided by x. Y runs from 0 to pi plus first integration of second minus in integration derivative of first into integration of second. So integration of second is what? Minus cos xy divided by x. Minus become plus, and derivative of first, derivative of y is 1 with respect to y. Derivative of first is, so we have this, okay, from 0 to pi. And then integration of cos xy is what? Is sine xy divided by x. Sine xy divided by x. Cos y integration, because with respect to y. And then we have this value, integration of y into this. And then its integration from 1 to 2. Integration of this 1 to 2. Value of upper limit, value at lower limit, similarly value at upper limits, value at lower limit. And then integration of this with respect to x here. Integration of this quantity is this. Its integration with respect to x is this. Again, with respect to x. 1 by x as first quantity, cos by x as second, first integration of second minus integration of second, derivative of first. Derivative of 1 by x is minus 1 by x square. So I can part rule, and then the value at the upper limit minus value at the lower limit. We have this answer after simplification. Integration of this part is, and then value at the runs from 1 to 2. We have the answer 0. Similarly here, here is the y notation, y term, this y, and then y in bracket, this integration is by using part rule. We have the answer 0. Similar problem, find the value of the solid S that is bounded by the elliptic paraboloid x square plus 2y square plus z is equal to 16. the plane x is equal to 2, y is equal to 2, and the 3 coordinate planes. Okay, so we observe S is solid that lies under the surface. Z is equal to fxy is equal to this 16 minus x square minus 2y square. Z is equal to, and above square R is what? 0 to 2. X runs from 0 to 2. Y runs from 0 to 2. Coordinate planes. That's so volume V is equal to double integration over R fxy dx dy. Is integration 0 to 2, integration 0 to 2. Right, this 16 minus x square minus 2y square dx dy. That is the problem is converted into two variable. Find z and then write z as f of xy, and x runs from 0 to 2, y runs from 0 to 2, and solve this integration. With respect to x first, that's why 16 is integration is 16x plus x cube by 3 plus 2y square, now constant with respect to x integration. So 2y square integration is 2y square into x. X runs from 0 to 2. Then find the value at upper limit. This is 88 by 3. And then that is substitute x is 2. And then x is 0. We substitute x is equal to 0. Then we have the answer 0. So this is the value at the upper limit. That is, if we substitute x is equal to 2, we have this answer. And if we substitute x is equal to 0 in this bracket, we have the 0 answer. And then its integration with respect to y. 88 by 3 integration is 88 by 3y. 3 or 5, check whether it is 3 or 5. I think 3, there is 3. And then the value, the integration of 4y cube is y square is what? Y cube by 3. So 4 by minus 4 by 3 y cube. Then value at the upper limit, that is substitute y as 2, we get 48 answer. And substitute y as 0, we get answer 0. So 48 minus 0, that is 48. So similar problems are here. Solve all these problems. Solve all these problems. Answers are also given. So these are some another problems. So in order to solve such a problems, we have to draw the figure. So first we will see this problem. Find the volume of the solid that lies under the parabol z is equal to x square plus y square, and above the region D in xy plane bounded by the line y is equal to 2x and parabola y is equal to x square. So this is y is equal to x square parabola. X square means around y axis. X square is equal to y. This is the parabola. X square is equal to y. X square means around the y axis and is above the x axis, because x square is plus y, and y is equal to another line, y is equal to 2x. This is y is equal to 2x. Okay, y is equal to 2x line passing through the origin. So the point of intersection is what? 2, 4. How we can find this point of intersection? Solve these two equations. Y is equal to x square and y is equal to 2x. If we substitute y as 2x, then we have the equation x square minus 2x. If we solve these two equations simultaneously, so that is substitute y as 2x. So 2x is equal to x square means x square minus 2x is equal to 0. Take x as common, then x minus 2 is equal to 0. Therefore, we have x is equal to 0. That is this point, and x is equal to 2. If we substitute x is equal to 2, then y is 4. So 0, 0 and 2, 2, 4 are the point of intersection. Okay. So D is the region xy. X runs from 0 to 2. That is above the region D in xy plane. Okay. So x runs from 0 to 2. 0 to 2. X runs from 0 to 2. We have to find the value of this solid part. So x runs from 0 to 2 and y runs from 0 to 4. 0 to 4. Y runs from 0 to 4. So y runs from x square to 2x. X square to 2x. So how we can solve this integration? That is, the volume V is equal to double integration over D x square plus y square. This is the region, suppose D. X square plus y square. Z is x square plus y square. dA. dx dy. So take the strip parallel to y-axis in order to integration with respect to y. So this integration, we can write this integration in two ways. So first way is what? Take strip parallel to y-axis. So right here, like this strip. So one end of this strip touches to the line x square, y is equal to x square, touches to the line y is equal to 2x, and another lower end it touches to the parabola y is equal to x square. So y runs from x square to 2x, and this strip runs from this to this. Therefore x runs from 0 to 2, x square plus y square dy dx. If we have to integrate this with respect to x first, then take strip parallel to x-axis, and then we have the limits. X runs from root to y, right here, root to y to 2x, y by 2, x runs from y by 2 to root y, and y runs from 0 to 2, x runs from 0 to 2, like that, y runs from 0 to 4. Okay, so we can integrate with respect to y first and then with respect to x. So here is the integration is with respect to y first, therefore take strip parallel to y axis, this parallel to y axis, and its one end touches to the line y is equal to 2x. So one limit is 2x and another is what? Is y is equal to x square. So x square is another rule. So write x square below and above 2x, or interchange the places of this limit. And x runs from 0 to 2, because in order to cover this region, we have to move the strip from 0 to 2, this to this, that is 0 to 2. So and then integration with respect to y first, because the the limit of y is in terms of variable. So in order, therefore this is the Hobini's theorem, that if the limit are in variable, limit of y are in variable, then integrate with respect to y first and then with respect to x. So here is the integration is with respect to y first, because limits are in the variable, and then with respect to x. So integration x square is what? X square y cube by 3, y is equal to x square to x dx, and then integration with respect to x, that is find up value of upper limit, substitute y as x, and then substitute y as x square. We have this answer, and then it's integration with respect to x. Okay, that is integration of x raised to 6 is x raised to 7 by 7, x raised to 4 is x raised to 5 by 5, x cube is x raised to 4 by 4, and then find the value at the upper limit minus, that is substitute x is 2 and then x is 0. We have this answer. That is, this is the, we can also integrate this with respect to x first. So if I have to integrate x first, then take strip parallel to x axis. So one end of this strip touches to y is equal to x to x, that is x is what? Y by 2. So write y by 2 as a lower limit, and another end of this strip touches to y is equal to x square. So x is root y. So y by 2 to root y, and y runs from 0 to 4. This, if you draw this line, then this point is 4. Y runs from 0 to 4. Y runs from 0 to 4. And then we have the same answer. So this is the change of, actually change of order. We can change the order of integration. So in order to integrate with respect to y first, take strip parallel to y axis, and in order to integrate with respect to x first, then take strip parallel to x axis, and then find the limits of from that strips. Okay, so we will see same type problems in the next lecture.